Hello, everyone. Is this working? All right. Great. Let's get started. James gave a bit of an introduction in the chat, so if you missed that, you can check it out. I have way too many slides for tonight. We're going to move quickly, but we're going over some high-level topics. We're not going to dig into a lot of code like the way I normally would, so we'll just try to move through it and see if we can cover a lot of ground. We're going to talk about cascade-aligned programming, and this is a term I made up, so if you're curious what is cascade-aligned programming, I have no idea. We're here to figure that out together. So we'll go through some of these ideas and see what we find. There's been a lot of talk over the years about object-oriented programming or object-oriented CSS and functional CSS, but these were both developed for non-cascading languages, and they don't feel like they fit exactly right, but I do want to look at where they do fit and how we might adjust them for the cascade. So the cascade is fundamentally different from any other language that we're probably used to, JavaScript or anything like that, anything that's an imperative language or doesn't have different origins of code. So we're going to start by looking at the mental model behind CSS, what makes it different, how the cascade works, why it's there, and then dig into some of the conventions. So when the web is formed in 89 and 90, this is the first web browser, the hypermedia browser and editor. You could actually edit in the browser. You can see that it was on a graphic user interface and supported some graphics fairly quickly. But it was for these graphic interfaces initially. This is on the next machine that they were using at CERN at the time, where the team developed the idea of the web. But they wanted to support every device, and not everybody had that next machine. People had these old terminals that were text only. And on that initial website, the www project, it says very clearly, if this is going to work, HTML has to be a common language between all of these platforms. It's going to have to work everywhere, or we're basically just recreating a new operating system. And that's good because now we have all of these different devices, all of them accessing the internet from with different browsers. So the web has to work in all these places, and they planned ahead for that. But then it goes on to say this implies no device-specific markup or anything which requires control over fonts or colors. And that's pretty problematic if we're going to do web design, which clearly we're doing. So something has changed here. How did we get through that problem? And the problem here is different devices are going to have different fonts and different color capabilities. Some are going to have only one font, only one color. So what does it mean to design in a world where different devices have different capabilities and we aren't going to be able to insist on our designs? That's pretty awkward. So they very quickly hired Nicole to make this second browser, which is a terminal line mode browser. There's an emulator online of both of these browsers. You can go play with them. But this browser, you interact with it totally through the keyboard. There's no mouse interactions, and it shows you the web, and you can get to today's web. There's a little bit of gunk from like character codes and stuff, but it all still works. And the idea was here we'll show you the way that this web is going to be platform agnostic by building a browser immediately that's less powerful than what we had in mind. And the way that that's going to work across all these different devices that have different capabilities is that browsers can ignore tags that they don't understand, HTML tags that they don't understand, they can just ignore them. And if they do understand the tag but don't understand an attribute of it, they can also just ignore the attribute. So down to a very fine level, it's very resilient. It falls apart silently. You just ignore anything you don't understand and keep going. So that's a very powerful, resilient feature that the web gives us. And it means that browser support's not a binary. When we ship a website, it is able to render in every browser unless we break it. And we can ship code that a browser won't understand, and the browser will still render that page as well as it can. So we don't have to decide what browsers we're supporting. We only decide what browsers we're actively breaking. In 1993 to 1994, there was sort of a style wars, and you can click through this link. I'll paste the link to the, actually, I want to do that right away, so you can follow along if you want to. Slides.netlify.app, shift remote, and I'll paste that here in the comments for you. There's a bit of a style wars that goes on there, and lots of people developing different ideas of how we might do styles on the web. And there's a lot of different proposals. Some of them are more HTML based, like HTML is. Some of them go way off in different directions. They're very interesting, but we don't have time to get into them. But one of those proposals is the Cascading HTML Style Sheets proposal by Halcon Lee in October of '94. And this is actually about 2 days after the Netscape browser shipped a different idea using inline HTML tags that would do styling inline. So cascading style sheets, what made them stand out really is this idea of the cascade, how the cascade is going to solve these various problems that we have with fonts and colors on the web. But also it needs to support style systems, right? So we want to be able to move away from inline styling where we're repeating the same style over and over again every time we need it. And we want to instead have a simple mapping between HTML elements and presentation hints that then allows us to style lots of things all at once with a single line of code. So that's the sort of style side of what CSS can do, and that gives us CSS selectors. So we get several different types of selectors. We do get inline styles if we need them, and then unique IDs can only be used once, reusable classes and attributes, element types, and the universal selector. So we've got several different ways of selecting, hooking into HTML to do those presentational hints. And then this is where we run into some problems, because we could apply multiple of these styles to the same element, in this case backgrounds on a button. We can apply them from everywhere. And so immediately we have a conflict. Multiple backgrounds on the same button, that's not going to work. What are we going to do about it? For a browser, when a browser is rendering, there's sort of a technical side of what the cascade is. When a browser is rendering, it needs to narrow down to every element has to have, every property have a single value. Every property of every element must have a single value. And that means we can't have any properties that are missing, and we can't have any conflicts. We need to resolve those conflicts somehow and find the one. And the cascade is what does that. The cascade is a set of rules that resolves value conflicts and makes sure there's one per property per element. And that happens in three parts. But it starts with style origins, which we don't think about a lot because we can't really manipulate it. So it's a little outside of our control, and that means that we're not interacting with it on a daily basis. Or we are interacting with it, but it's sort of outside the code that we're writing. And when Halcon talks about this, he says, this proposal tries to soften the tension between the author and the reader. author and reader are two of the different origins, and he has this sense that the author is going to want things to be more similar, more under their control, and the author is going to want more uniqueness, more branding, things like that. So what we do is we have an ordered list or cascade of style sheets that can be referenced from the same document. And we're often not using more than one that we attach. We're attaching one style sheet maybe, sometimes multiple, but often we're pulling them all together on the server side before we ship it. But the browser is also sending a style sheet, and the user is too. Now, these days, the user doesn't interact with that style sheet directly most often. They're usually going through the preferences, both the operating system preferences and the browser preferences, but those preferences get combined basically into a style sheet that is added to our documents. So we've got these different style sheets that are coming from different origins, the user agent or the browser, the user, and the author. And we're trying to balance their intents. What are they trying to accomplish, and how do we balance that power between them? Like I said, authors are going to want a distinct look and feel, while users are going to want all documents to appear more similar, or at least to have control over those documents, to make the font bigger or smaller, to up the contrast ratio if they need to, and to view it on different size screens. And then, of course, we also have the browsers themselves need to say what they're able to do and what they're not able to do. So the user or browser specifies initial preferences and hands the remaining influence over to the document, over to the authors, that's us. They go first, and then we come in and do the remainder. And those are similar to specificity, which we'll talk about in a bit. Those origins are stacked in layers. We've got the author layer on top of the user layer, which is on top of the user agent styles. So the browser first gives defaults, and then the user can set some preferences, and then we can come in and blow them all out of the water. But we really wanted a balance of power here, so that doesn't quite work out. Haakon says the user should have the last word, and authors should just be attaching style hints, which is backwards from what I just said, and that's the reason that we have importance. It's there because it flips these layers. It creates a second set in a flipped order where user agent can set important styles that will beat out over everyone. The user can set important preferences that will not be able to override the browser user agent, but will be able to override us. And then we have this second layer of important styles. And our two are basically right there in the middle, and so we often think about it important as being a layer of specificity, but it really is this separate thing, this flipped order balancing the power between different origins. It also gives us that balance of support with browsers, and this is language that he repeats over and over and over. We're providing hints that the browser may or may not use. And that's fundamental to the idea that this language is going to be resilient and it's going to work on every device. And you can ship CSS that the line mode browser will just continue to ignore. It may or may not use our code. And that's fundamental to the Cascade. So we're trying to design for the unknown, unknown sizes, unknown interfaces, unknown preferences, even unknown content these days, which is really just too many variables. If we were trying to do this in JavaScript, just imagine trying to write a simple calc function with user preferences coming in on font size, and then we're trying to adjust the font size based on browser width, and then maybe we're also factoring in the other font sizes around the context somehow. There's no way that we would be able to write all this out in an imperative language in a reasonable way. It wouldn't be performant, and we would have to be reinventing the wheel every website. So CSS is there to make sure that we don't have to worry about all of those different variables. We define a few constraints and let the language work out the details. And it's pretty smart about what Normal flow, the defaults are very intelligent. We get normal flow that moves things around based on the content and tries to figure out what's block and what's inline and how should they lay out together. So we get a lot by default that tools like InDesign wouldn't be able to give us. They're not that powerful in terms of doing the layout for us. Web browsers are doing a lot of work for us, and so our job is just to tweak and define some intents. It also means that there's always a fallback option. Because of this cascade, we can always fall back to an earlier layer and see what's there. Getting into selector specificity, which is where we spend most of our time, and we often think of everything we do as part of specificity, but it has a very tightly defined meaning. It's sort of a layering system. If you think about the way that we might paint with broad strokes and then do details over top, or if I'm working in InDesign, I can create character palettes, and I can apply a character palette to lots of different items, sort of a broad pattern. And then I can click on a specific item and I can say, okay, but this one, I want it to be slightly different. And that's what specificity is trying to capture. Our ability to do broad strokes that are going to hit everything, and then come in and do finishing touches over top and get the details right. And the details should always override the broad patterns. So again, we're sort of thinking about different intents. We've got universal type selectors that we can use for global defaults. We've got attribute selectors that help us create common patterns, and then we can start combining attribute selectors to create reusable components that are composed of smaller patterns. And then we get IDs there for really detailed singular overrides. This is sort of the vision behind it. It doesn't work out perfectly because there's a lot of limitations here that weren't quite forward thinking enough about what we're having to deal with. And I think this is something that the W3C could think about addressing. I think specificity gets at the idea right, but maybe needs some updating here. But that's the idea, and it makes sense to me. We've got these layers of intent, and we want to sort of build up one layer on top of the other. So each selector has a weight based on how specific it is, and those are often, when we talk about them, people will represent them as numbers using factors of 10 to calculate what the specificity of a selector is by adding up all these numbers. It looks something like this, where the universal selector has a specificity of 0, and then element types have 1, and then classes and attributes have 10, unique IDs have 100, and inline styles have 1,000. But it sort of implies that if we add them together, we can say, okay, button, that's 1, class of action, that's add 10, another attribute, add another 10, plus the universal selector is 0, so we've got 21. And that's how a lot of people will do selector math. But it sort of implies that we could add up 10 classes and they would equal an ID. And that's just fundamentally not how it works. 10 times 10, in this case, is not equal to 100. So I don't recommend that approach of calculating selector math. There's an easier way to look at it. I think of it like versioning. There's other ways that you could picture this, but really we're talking about separate layers that if we go up from 3.9.5, we don't automatically version up to 4.0. We can go 3.10.5, and we can keep going up, 3.11. We can have 3.462.5, and that's the way that selector layers work. They're separate, and they don't flow over into the next layer. 3.462.5 is still less than 4.0. So really, when we're looking at selectors, all that we have to do is check the first column. And that's true at every layer of the cascade. We check the first column for origin. Are any of them coming from the highest origin? If any of them come from the highest origin, we can move on. In this case, looking at selectors, it would be inline styles or IDs, whichever one we want to put at the front there, wherever we're starting. And we can just say, that first one, it has a 2 in the front, so it wins. We can ignore all the other numbers. And we only have to move on when they're tied. So these both have one ID, so then we have to look at the classes, and one has 12 classes and the other has 3. That's terrible. I don't know why anyone would use an ID, 12 classes, and two types, but there it is. We only have to look at one column at a time to compare. It's a little bit like we're sending our code down through these mechanical sorters over and over again. And we can immediately ignore the empty columns, and then we can ignore everything except for the biggest column. And then we just have to take those coins. If we're looking for the largest coin here, we take those coins and we pass them through the system again. And we pass them through the system at each layer until we get what we're looking for. So first we do this with origins, and if they don't match, then we do it with selectors. And if they still don't match, we go to source order. It's sort of the final tiebreaker of the cascade. There is only one that comes last, and that one wins, unless it doesn't, and we'll talk about that. But that gives us the ability to say something like, here's 2 backgrounds, use the second one. And there's a reason that we do that. It's so that we can fall back on the first one. But the cascade is this filter. It gets rid of all the extra values. By going through that process, we get down so that we just have one value. And then inheritance comes in, and inheritance fills in anything that's missing. So we said every button has to have one background color. It has to. So if we had multiple, the cascade will filter it down to 1. And if we had none, the cascade will fill in with inheritance. And the top level of inheritance isn't the browser styles or the user styles or our styles. It's going all the way back to the specification. So the specification has an initial value, and that will get filled in at this point if inheritance can't find anything anywhere else. So inheritance helps us paint with even broader strokes. We don't have to repeat the font at every layer down into our DOM. We can set the font once and it will inherit everywhere, and that sort of helps us get through things faster, keep things drier. And really with all of this, I think CSS is doing the impossible. I mean, very basically, that first website said it couldn't be done, said we would never have colors and fonts on the web, and CSS is doing it. It's unlike anything else, designed for the realities of flexible, multilingual, multi-device web, and that's just fundamentally different from any other platform. It's graphic design of unknown content on an infinite and unknown canvas across operating systems, interfaces, and languages. This is absurd. It's absurd that we're even trying this. So when people think that CSS is a bit complicated or hard to follow, this is why. We're basically doing the impossible, and we're trying to simplify that down as much as we can and get a little bit of ability to make those hints and suggestions that Håkon talked about. We already saw that quote. But so that comes from Keith Grant's article called Resilient Declarative Contextual, which is a great article. I highly recommend it. And I want to talk about sort of the 3 things that he's pulled out there. I think they're important. CSS is resilient. It's going to do that, ignoring tags, ignoring attributes. In CSS, that looks like it can ignore selectors that it doesn't understand. It will ignore the whole block. And it will ignore declarations that it doesn't understand inside of selector blocks that it does. So even down to, again, to a fine grain, CSS is going to use everything that it can and throw the rest away. And that makes it fully forward and backward compatible, and gives us this, where both of these colors are likely to be used. A modern browser that understands CSS variables will be able to use the second value, and an older browser that doesn't understand variables will be able to use the first value. So we're able to very quickly sort of fill in the gaps for forwards and backwards compatibility in a lot of cases because we have this resilience built in. We also have it built in some places in the design of values themselves. Font stacks are an acknowledgement that a browser may not have a font, a device may not have a font. So we need to fill in with suggestions of other fonts that you might be able to use. And again, we're going from the most detailed, it's sort of reverse of selectors. We're going from the most detailed down to the most generic. We also get things like supports. This is more recent, and we're not going to go into it in depth, but we can actually do feature sniffing, basically, and fill in gaps for older browsers or fill in gaps for newer browsers, however we want to think about that. Again, we're not supporting browsers in a binary world. All browsers are able to access our code all at once, and our features are working and not working at the same time, and different features are running in different browsers, and that's okay. That's how this was designed. That's how it's meant to be. So Cascade-aligned programming has to embrace that. It has to be a progressive enhancement somehow. It has to understand that browser support is not on or off. It's progressive. CSS is also declarative, and that means it relies on meaning and intent. The browser is making a lot of decisions for us, and that means we're trying to communicate as much as we can to the browser about what we mean. And that's why HTML as a markup language is basically TypeScript for content, right? We apply these types to every bit of data in our content so that the browser can be smart about how do I handle headings, how do I handle lists, how do I handle paragraphs. The browser is making a lot of internal decisions based on that code, so we have to give it as much to work with as possible. That meaning and intent is important. And we do the same thing in CSS. We have different units that describe different intents. Even though 16 pixels and 1em might sometimes give you the same font size, they mean very different things, and the browser is handling them very differently. So we get these ways of providing semantic meaning to the browser in very quick ways, just all wrapped up in that em value. Similarly, one fraction in a grid, sometimes that might be half of the grid layout, but it's a very different calculation, a very different meaning, very different semantics internally than 50%. So we have to be careful that we're always expressing meaning because we're providing hints and suggestions, and the browser has to make the final decision about what it's going to do and how it's going to adapt to different situations. And the more we help the browser do that, the more the browser can figure it out in smart ways. CSS is also contextual. That's the third thing that Keith lists. And partially that's because design is contextual. There's no way to design in isolation. The paragraph on your poster, or the big heading on your poster, if you change the background color, you have to change the heading color. That's just the way design is. Everything is relative. Everything is related to other things on the page. And design is always contextual. There's no way to isolate design. And that's why we have things like media queries. We can sort of make clever hints and suggestions about what to do in different situations. We can get a little bit more specific there, help the browser a little bit more understand what we're trying to do. So that means Cascade-aligned programming has to be adaptive. It has to be responsive. It has to flow with those differences and the way the browser is making decisions for us. And then also, we're collaborating on the web. And I think this is the thing that we sometimes forget. The web is a collaboration between the browser, the user, and us. And those early CSS proposals, the biggest fights were over how much power we get versus how much power users get. And the designers of CSS were adamant that users should have as much power as possible. So we want to be leaving that power for them. We want to be, in fact, helping them get good results from their preferences. So we have things like prefers color scheme dark, prefers reduced motion, prefers contrast, things like that. So Cascade-aligned programming would also have to respect other origins, not be focused entirely just on what we want as authors. The Cascade is all about balancing these concerns, about balancing branding with preferences and systems with details, broad strokes with minute details, context with modularity, control with resilience. We're trying to balance all these ideas. And we do that by defining as little as possible and communicating those intents, providing those meaningful units and intrinsic sizes. Intrinsic sizes we now have access to through like min content, max content, and a few other sizing values. We have normal flow that does all the smart layout for us. It's a very intelligent layout system that we sort of think of as just the air we breathe. We don't think about it a lot. Yeah, so some of this is a little repetitive, and I'm going to try to keep moving. So we're going to try to help browsers help the users. And then that will also, the more meaning we can pack in there, the more useful that is also to other developers as they read and understand our code. This is just a quote from Anne Bogart. She's a theater director that I've always found inspiring, who talks a lot about this idea of making art that is seen differently by everybody and isn't about forcing everybody to have the same experience. It takes craft to set up circumstances that are simple and yet contain the ambiguities and incongruity of human experience. And I think that really captures what we're trying to do with web design. So now we're going to look at some of the systems that people have tried using and how they do or don't fit into this. And I want to go back to sort of the first one that I really interacted with, Natalie Downe's CSS systems. This was a talk that she gave in 2008. I was not there, but I saw it online. And it really struck me, and I really liked what she was talking about. And it was the first time that I started thinking about how are we doing systems in CSS. And she was really reacting to this a year or two earlier. A lot of major grid frameworks started circulating. Blueprint, 960 grid systems, etc. And there are all these centralized class libraries. So you would download a CSS file with all these classes defined, and then you would start just applying those classes in HTML. And most of them had pretty similar syntax, something like this. You've got a column. It's 6 of 12 is the width of the column, how it spans the grid. And then last column would remove the final gutter because we're doing gutters with margins. This is all workarounds in floats and margins and widths, percentage widths to get this all working. And actually, a lot of these would have been set widths, 960 GS for sure, because we didn't actually have media queries at that point, or they weren't commonly supported. And they would provide one universal grid, but they'd be hard to customize. So you might get stuck in this place where you've used it, but then you need something custom and you're kind of stuck. Or if you want to make one change, you've got to pull out the whole system and try something different. And she was sort of responding to that and said, okay, these CSS frameworks, they're causing too much bloat and they decrease the maintainability of our code. They're not part of the system we're defining here. There's some external something, and it's not helping. So she was proposing that we develop conventions over frameworks, which is exactly what we're talking about here today, CSS conventions. So what are the conventions that we're going to use? For her, a convention had to include shared vocabulary, reusable patterns, and the ability to personalize styles. So we're not making the same website for everybody. We can personalize those styles. It's not just going to be Bootstrap everywhere. It's going to be our own tiny bootstraps for every client. I think that's a quote from, now I'm blanking on his name. She ordered hers based on specificity. So this is very much based on ideas of the Cascade, how the Cascade works. Let's use that for our ordering. So she broke that into 3 categories: elements grouped by type, classes grouped by effect, and then IDs grouped by component. And that would be the order of your code and also some guidelines on how we use these different selectors so that they layer correctly. Within that, she broke those apart into many more layers. So starting with general styles, which included resets and basic links and headings. Helper styles, which sort of give you defaults for entire forms or notifications. Common patterns that are going to be used across lots of sites. And then page structures, header, footer, layout blocks, and then the components. And she said most of your styles go here. In my mind, I try to push them up as much as possible. I always feel like styles should go in the highest layer they can possibly live in. What is the broadest pattern we can define that's still useful and meaningful? But she said most of your styles are going to be components. And then right at the very end, our smallest layer is going to be overrides. We're going to avoid these as much as possible, but every once in a while we're going to have to come in here and override one of our patterns. She also proposed that all layouts should be built fluidly on the inside. So she would create a container that could be described in ems or some other unit. She often used ems because then a site was both responsive to the font size and the outer viewport width. And then she would put a max width of 100%, and that makes sure that it never overflows the body horizontally. And then all internal layout would be done in percentages only. And the advantage here was that you could work on a grid and then you could say, actually, I need this grid to be 2ems bigger at its largest. And you could just make that change one place and everything else flows to adapt. She also said, don't overly sandbox. If you go read her slides, you'll be like, why is Miriam just giving her talk? I'm not. Her talk is good. Mine is different. But she said, don't overly sandbox. We want things to be as reusable as possible. So we're going to focus on what we're styling, not where it is. And that means we're going to avoid doing long selectors like this, where we say, okay, it's on the page, it's in the teaser, it's the products, and then inside of a list item, we have a paragraph that's the name. And she says, okay, that's too much about where it is. I just want to know what it is. What's important to actually what we're trying to style. And what's important there is what we want the name of a product. So we trim it down to just that, not overly sandboxed. And then she says, let's up and down the font sizes constantly as we're working, which I still do. You know, this ability to change font sizes real quickly in the browser and see everything move around helps us with that developing for difference, for change, for the unknown. And she says, don't engineer separate solutions. This is back when people were doing IE-specific styles. But as much as possible, we're trying to engineer one solution that's going to fall apart or progressively enhance for all the different browsers. We're not trying to re-engineer specifically for every browser. And I would still recommend this for, say, grids. I think there's a lot we can do with using grids and then providing very simple fallbacks for them. Grids go so much faster than building floated layouts. We can ship them already and still support IE 10 or IE 9 or whatever, just by providing simplified fallbacks, not trying to re-engineer the entire solution in every browser. So then the steps are to define it, develop it, maintain it, communicate it. And I think communicating it, that's a very important point. If we don't communicate a system that we've built, it's not a system anymore. It goes away very quickly as soon as somebody touches it. So the next year, Nicole Sullivan came out with her very popular object-oriented CSS that builds on some of these ideas and goes in a slightly different direction. She's mostly focused on reacting to code reuse and saying, okay, people aren't reusing the same code enough. We're basically getting in the situation where we have one-to-one new code for new component, new code for new page, and every component we add, every bit of complexity we add to a site gets that much more complexity in the CSS. And that's not what we want. We want some way to not have CSS grow at the same rate. And that means more code reuse. So she proposes thinking about it in terms of object-oriented language and thinking about a CSS object as a repeated visual pattern. So this could be like a card, or the media block is the one that she proposes still used in every framework out there. A repeating visual pattern that can be abstracted into an independent snippet of HTML, CSS, and possibly JS. We're trying to take systemic design beyond just reusable components and instead say some of these components share patterns. We want another layer of abstraction above that and have code that components can reuse to give us, at that point, rounded corners, I think was a very popular shared pattern that might be used across components. So her rules are that we're going to separate structure from skin. We're going to, the object structure needs to be as minimal and reusable as possible, just enough to do what that repeatable pattern needs to do, just enough to give us those rounded corners. And then we want to be able to skin it separately. And that means, what color is the card? What color is the border? Does it have borders? We want to be able to create theme options so that every component that uses this can use the same basic structure and then just make slight adjustments to the theme. Additionally, we're going to separate container from content. And that just means that we want to be able to put new content in somewhere and have it fill the container the way it should. We want to be able to change the content without changing the container, and vice versa. So she's suggesting rarely using location-dependent styles, and that might sound similar to not overly soundboxing, styling what instead of where. I think what's really interesting about this one, and the reason that it maybe we latched onto it as a community, is because CSS clearly comes out of some object-oriented language and thinking. We do style objects on the page. We have individual elements on the page that are, in fact, instances of a class, which is very much object-oriented programming language. And each instance can have individual attributes or instance variables as a way to adjust them. So HTML and CSS, we're very much dealing with objects here. This makes sense. We can even do object composition where smaller objects are combined to create a larger object. So if we put a name with an address, now we have a person, and we can sort of build these bigger and bigger structures, which is exactly where Brad Frost and Atomic Web Design come in. And for Brad Frost, this is less about how we write our CSS and more about how we think as designers. This is about a design process. Very different from Atomic CSS. That's a completely separate thing, and he has nothing to do with it. But he's saying, let's start with some small components that are very simple, atoms, and then like these, a label, an input, a button, and then we can put those together into a molecule, which is all three of them together in a specific arrangement. And then we can build molecules into larger organisms and build those into larger templates. And really, 2009 to the present, ever since OOCSS from Nicole Sullivan and CSS Systems from Natalie Downe, I feel like we've been repackaging and sort of slowly adding to these two basic ideas. The one being, how do we think about building systems of vocabulary that follow the cascade, and the other focused on how do we build reusable patterns that minimize our code bloat and help us make meaningful objects. And these two things get merged and adjusted, and people push them around in different ways. SMACSS is very much OOCSS with a few other terms thrown in, and organized by category. So this is one piece that SMACSS adds. This idea of 5 layers. There's the base, layout, module, state, and theme. And you can see theme there is basically the skins that that Nicole was talking about. And layouts and modules, all of that is stuff that they were talking about. But he breaks them out here. I think an important thing that he adds here is state. And that's something that we'll want to talk about. He adds important to every state, which is sort of a utility class approach. I think I've never really done that. I have a few other ideas on that. ITCSS, inverted triangle CSS. I like this one a lot, but it's very much CSS systems with a little bit of OOCSS and some pretty pictures. So let's look at those pictures. So it's an inverted triangle, and what he's saying here is basically what Natalie Downe was saying with her 3 layers of types, classes, and IDs. And he's just saying, okay, so let's put those into a triangle and let's match specificity with explicitness, and think about how broad the reach of something is. If you don't like it inverted, you can just look at it right side up. And this is my triangle and has nothing to do with Harry Roberts. But type selectors give you that broadest reach. A P tag is going to style every paragraph on the page no matter what. So that's a very broad reach, and it also has very low specificity, and it's not very explicit about what it's trying to style. And then we want most of our code to be there. It's the base, it's the shallow end, however you want to think about that, and it's where we put as much styles as we can. Like I said, stay as abstract as we can, and then slowly add detail. Moving towards the top where we would have IDs and stuff. So again, thinking about narrow reach, broad reach, how many elements are we styling? That's the one axis. And then low to high specificity, what's the weight of the actual selector we're using? And then generic to explicit, what's the desired impact? So he's saying the higher specificity we get, the more we can be explicit about what we're trying to do. So this would match the idea that something like a text center utility class would want a very high specificity because it's very explicit about what it's trying to do. Whereas when we're styling a paragraph tag, we're trying to be general. We're not very explicit. And we have a broad reach, low specificity, low explicitness. He breaks that down into layers. I didn't like the trumps layer, so I changed it to overrides here. But I use layers similar to this. Mine are slightly different, but the same idea. Settings and then tools. Those are very broad. And as much as possible, we want things to be figured out at that layer where maybe we don't even have any CSS output. Maybe we're doing all of that in Sass or somewhere else. And then generic is where we'll start to have actual CSS output, styling generic tags. And then elements, we could call those atoms. Objects, we could call those molecules. It's the same idea, building up specificity. We'll talk about scoped styles a little bit later, but I tend to think of them as existing very much at those. We want to use them sparingly and for very specific use cases. At OddBird, we use a real mix and match approach. We're not using one of these very strictly. We're mixing and combining and taking ideas from them. But we sort of organize our code by reach and complexity. It's sort of a combination of those two ideas. So tools and config right there at the top, and then we'll have sort of initial, general, generic, and then very reusable patterns. That's sort of the objects layer, or the first objects layer that Nicole Sullivan's talking about. And then layouts and components are ideally pulling on those patterns and reusing them as much as possible and just doing minor tweaks to make them work for specific, put content inside of them and make them do exactly what we want, put on the attributes for each instance. So we're using some combination of all of these: CSS systems plus OOCSS plus ITCSS plus atomic design plus all of these ideas. I don't think that one of these is the final truth that we should use. I think they all give us useful concepts to think about. When we're using JavaScript frameworks, we get these single file components and this ability to scope styles. And scoping is a little bit different from specificity or context. It's about ownership. It's not just is this button inside of the contact form. It's is this button owned by the contact form? Is this button owned by the call to action? And a visual that this is something that Nicole Sullivan talks about quite a bit. She calls it the donut problem. But we're trying to convey like tabs are a good example that she uses. Tabs own the tabs along the top, and tabs own the container that content will go into, but tabs don't own anything inside of that content container, right? So it's this donut. Tabs can create a donut of what they own. And it's not just everything that's nested inside of them. So it's this idea that we can have an isolated component that doesn't bleed into its subcomponents. In a tool like Vue, we can think of it like this, where we have an article component and a slot where we can put in a subcomponent, and we have a footer there and a header. So we've got, in this case, the header and the footer are owned by the article, but the subcomponent, anything inside of it, is not owned by the article. It's outside of this scope. So the way JavaScript frameworks do this is basically they add, and they don't do it quite as pretty as I have here, but they basically add attributes that say, here's a scope, and then we'll apply that scope to not just the article component, but everything that it owns will get it. This subcomponent will get a scope of article, and we wouldn't want to actually repeat that. We would want to just have article sub. So it gets both of those scopes. But anything inside of it does not. It only gets the sub scope. And then the footer again gets that data scope of article. And we've now established ownership, but we're having JavaScript frameworks sort of apply that for us based on how we've written our HTML. And then they do the same thing with our scoped styles. So they take anything styling an article, H2 or footer, and they just add those scope selectors to it. And now it is specifically only targeting an article that is part of the article scope, or H2 that is part of the article scope. And that's actually something that we can do on our own. We can create scopes like this. We can also add instance IDs to them so that we're able to target a specific instance of a specific scope. There's a lot we can do here if we want to, either automated or not. I want to talk a little bit about naming conventions, sort of the last piece of this. So we've talked a little bit about organizing around the Cascade, but now I want to think about naming conventions. They're the other piece of creating a system. The most popular one is block element modifier, BEM syntax, which is very much based on OOCSS, but then taking Nicole's warning not to be overly specific about location and making that an absolutist rule that we will never use more than one class on anything, basically. But it defines a block as a standalone entity. And I think this is a useful way to think about it. It's sort of like the way that Brad Frost would talk about an atom. An atom is a standalone entity, and then working up from there, all of them are standalone entities. Anything that you can look at and say, this exists as a thing at any level, so you can nest blocks within blocks. An element for BEM syntax is always part of a block. It is one of the things owned by a block. So it's basically building scoping into this naming convention. Blocks own elements. Every element is part of a block. It doesn't have meaning on its own. It only has meaning in context. And then we have modifiers, or these can be skins or states or however we want to think about them, something that modifies that block, arguments that we're passing in, a flag on a block, changes the appearance or behavior. So this isn't based on the size of the elements or their complexity. It's based entirely on is this standalone, or does it belong to something else? And then selector naming is done all with single classes that are compiled using this syntax where we get the block, and then we can put a class on an element that's part of that block, and that's called block underscore underscore element. And then we can add modifiers with 2 dashes. So it's sort of stringing it all together into one place. And what I do like about this is the clarity of relationship structures. I think it's useful to be able to say, this element doesn't exist on its own. It's always part of a block. Making those ownership relationships, that scoping relationship, that's very useful. I don't like the idea of flattening selector structure this much. Being able to layer selectors is a very important part of CSS. And if we get rid of that, we just have equal specificity on everything. And then a JavaScript framework comes along and loads our CSS in random orders, and we don't even have control over source order. So we basically have given up control of the Cascade entirely at this point, because everything is a selector with exactly the same specificity. We don't control the source order anymore. Now we're throwing in important on everything because it's the only way that we can say what should override what. So I think BEM breaks the rule of being Cascade aligned in that way. So I suggest instead combining selectors. Have ways of describing scope and specificity in meaningful ways. And we'll look at some of how I do that. And I think also there's some changes that we need in the Cascade, and we're working on that. So SMACSS uses layer prefixes as part of its naming convention. Everything in the layout layer starts with L dash. In the component layer, it starts with C dash, etc. And then states start with is dash something. And those are clear. Those are a useful way of layering, except, again, I don't think they quite capture the way that we want layers to override each other in a specific order. So we're not quite capturing that in here because it's all happening inside of a single class name. I think it also is an attempt to sort of group our styles in different ways, but it's all based on conventions, and I don't like that. I think there's a way that we can take, say, these state types, is collapsed, is error, is hidden, and we can use built-in attributes where they're available. So we've got aria hidden, we've got hidden. Those don't do exactly what most usually we need some sort of visually hidden but accessible to a screen reader, so we'll need to create that on our own. But like is hidden can turn into these attributes that we're already provided. Is collapsed has attributes, aria expanded, aria pressed. And then we can start to create namespaces of our own using data attributes. The data prefix is required for JavaScript to access these through a clever shorthand syntax, but it's not required for it to work. Technically, anything with a dash in it will be safe and future-proof the The W3C has promised to never make an attribute with a dash in it. That way, anytime we put a dash in an attribute, it's ours. So we can create these custom attributes that sort of namespace and group things. So we can have data layout something instead of saying all of our classes are in the same namespace and we're going to give them these prefixes. We can actually pull things into separate namespaces and start to group them together with data attributes or any custom attributes. So is success and is error, I would get rid of that is dash, and instead I would create a in this case, these are specific to messages, so I'd create data message, and then we get success and error options. These are sort of the arguments that we can pass into our message, the different states it can have. That also gives us the base attribute, so we can style like what does any button look like, and then what does a success button look like on top of that. We get these variations within that namespacing, and I think that's a handy thing that we don't use enough. People complain a lot about classes being universal, and this breaks us out of that. I'm not going to go into these, but there's lots of different ways we can select on attributes to get very specific, including case sensitivity. And then one of the final things I want to talk about is recent trends in atomic or functional CSS. I haven't played with these a lot because when I look into them, they don't seem to solve a problem that I need. But the idea goes back, I think roughly 2013 is when I've been able to find sort of the earliest ideas of this. And the idea is that we take utility classes and we only use them. And I want to acknowledge we've had utility classes the whole way through. They have uses, especially something like a clear fix or screen reader only, where they're only there for utility. They're not there for presentation or anything. Column 3 of 12 is sort of a utility class, not to the extreme that atomic CSS would want, where it's actually often a single declaration inside the selector. But to a level, it's still the same idea. Those can be very useful. But once we start using them on their own, we're basically just moving our problem from CSS into HTML. So if it's useful for you to have this all in one place like this with a, I think this is a very cluttered syntax that's hard to read, but it's doing the same thing. You're just applying these single declarations in the HTML instead of the CSS. I kind of don't get the point to it, but it works. It doesn't hurt something. It just means you have to deal with it all in one place. And I was trying to think, like, is CSS functional the way that CSS is object-oriented? And I think in some ways it can be. We can sort of say, we can sort of think of these classes as functions that we're composing together, like it's an alert and then it's an error, and this is the composed result of a paragraph that is also an alert and also an error, and we've put those functions together. There's something functional about that. But selectors can never be pure, and I think that's where it falls apart. In the attempt to make every selector pure and do one thing, we forget that CSS is all about context and design is all about context, and there is no purity here. We will always have all of these cascade side effects, even if we just move all of that complexity into individual classes that we put in our HTML. CSS is all about side effects. There's no way to avoid that. We can't avoid that. We won't avoid that. It's always going to be there. So in that way, we can't do what functional programming is all about, which is this isolation and avoiding side effects. So going all in just moves the problem from one place to another. I don't really see the point. I think it's great to use utility classes where they're meaningful, where they really get at what we're trying to do, the purpose of them, and they're not as useful once they start representing everything. I mean, I think also don't repeat yourself is a really good idea. We want to be able to have this warning class that we can reuse multiple places, and everything that's a warning looks kind of the same, and we've got this dry code. That's wonderful. But as soon as we start stretching for patterns, and I know that this doesn't roll off the tongue, But as soon as we're stretching for patterns like this, they fall apart. If we want to make a change to what a warning looks like, we have to make a change everywhere that we've applied that red border. That red border no longer has a meaning. It's just a red border. So we lose some of the usefulness of semantics, and we're not conveying meaning with our objects. So closing it up, what is Cascade aligned programming? I think it's the ability to express layers of intent and describe those layers and build them on top of each other and say components are more specific than our global reset, and we want those layers to stay intact. And having a wider cascade actually allows for more nuance in our layering, shoving everything down into single classes, and then eliminating our ability to do source order. We're narrowing our cascade, and that's where we get frustrated and find that we're adding important to everything. What we really want is a wider cascade that we can move things around in to make sure that they layer correctly. And I think the W3C needs to update and extend the cascade. I think it's outdated. And I actually just got off a call with some of the CSS working group talking about how we want to do this. We're going to be making a proposal soon. Because I think it is out of date. It doesn't quite do everything we want, but it's a good approach. We need more nuance, and we're getting some of that. We're getting the where and is selectors that are going to allow us to manipulate specificity a little bit more. We're getting potentially down the road scope styles, custom elements, web components, shadow DOM. A lot of that is still being worked out. It's not an easy problem, but hopefully we're going to get something like that. Custom author layers is what we were working on in the call before this. And it would be the ability to actually set up layers like this explicitly in our CSS and have them override each other in the way that we want. Also, CSS custom properties can do a lot for us right now. The way that they interact with a cascade can be very useful. Follow this link at the bottom to the article on CSS tricks, where I talk a lot about manipulating the cascade, managing the cascade, using stacks of custom properties, where I can say that the button state should override the button type, which should override the button default, things like that. So the cascade is important. It's useful. It's not going away. We're never going to be able to avoid it. Even if you write your CSS in JavaScript, it ends up being CSS, and it ends up in the cascade. And the cascade is always going to be there, and we need to learn to use it. Thank you. I'll stick around in the chat for a little bit to answer questions. I know I went a little over an hour there, but